MBA633 instructional video prepared by Professor Amit Tata, School of Management, George Mason University. In this segment, we'll introduce some definitions and basic concepts associated with hypothesis testing. You will notice similarities with confidence intervals that we had covered just before, in the sense that here also we will be trying to make some inferences about a population based on observations on a sample. Hence, there will be uncertainty associated with that inferencing, and you will also find that the quantification of that uncertainty is also based on the sampling distribution of the sample statistic. But that is where the similarities end. The objective of hypothesis testing is somewhat different from that as compared to what we saw in confidence intervals. If you recall, when we were doing confidence intervals, we were actually trying to estimate the population parameter, and we tried to bracket it between a lower bound and an upper bound with a certain level of certainty. As you recall, we said that no inferencing can be done with absolute certainty. In the case of hypothesis testing, the aim is somewhat different. Here we try to, as the name suggests, state certain hypotheses about the population parameter. In other words, there will be a claim and a counterclaim, and based on what we see in the sample statistic that we observe, we'll try to determine which of those claims might be true. Very well, then let's take an example to set the stage here. So we have an insurance company which is reviewing its current policy rates. Originally, when it set the rates, they believed that the average claim that they received was $1,800, and now they're concerned that the true mean is actually higher and that they may end up losing a lot of money. So let's take those two sentences, and if you think about the narrative, you can see that the population that we are referring to here is the set of all claims faced by the company. So previously they believed that the average of the set of all claims was $1,800, and now they are concerned that that average might have actually crept up, might have gone up. So you can see that the population parameter that they are concerned about here is the mean, the population mean. So the claim and the counterclaim that we make here is that the counterclaim that we make, which in statistical terms is called an alternate hypothesis, is that the average is greater than 1800. That's what they suspect has happened. And originally when the policies were set, they believed that the average claim was $1,800, and we set it up in this manner that we state the claim as mu, the population mean, as being less than or equal to $1,800, so that the claim together with the counterclaim covers all possible values of mu. Again, in statistical terminology, the claim is what is called the null hypothesis, the counterclaim is what is called the alternate hypothesis. And in this case, given the narrative of the problem, they originally believed that the average claim was $1,800, and now that it has crept up. So our claim and counterclaim that we have for this situation is mu is less than or equal to 1800, mu is greater than 1800. So claim and counterclaim. So our job is to find out which of these two might be true. If it would be nice if we could check all claims, but we cannot. So what we do is we check a small sample of, a sample of 40 claims, and we find that the sample mean is $1,950. So based on this statistic that we observe, this sample statistic, we have to choose between these two. And you can guess by a logic similar to what we had in the case of confidence interval, because of the vagaries of sampling, we can never be absolutely sure in making this call. So what are the possibilities that could arise? For example, let's take three different scenarios. So let's say instead of 1950, if the sample mean had turned out to be $2,100, then just intuitively I think you would feel fairly comfortable in saying, I think I will reject the null. This mu less than or equal to 1800 is probably not true. On the other hand, if the sample statistic, instead of being 1950, actually turned out to be $1,825, you'd be a lot less sure. You'd be less inclined or be less sure about rejecting the null. You say, well, maybe the population mean is in fact less than or equal to $1,800 because I'm so close to it. So you can see intuitively, the further away you are from this presumed value, the more sure you are about rejecting this particular claim. Of course, the quantification is how far does the sample statistic, how extreme does the sample statistic have to be away from the presumed value, the claim, in order for you to be reasonably sure that you're not making a big mistake in rejecting the null. Okay, so in terms of the definitions that we've introduced so far, we have the null hypothesis and the alternate hypothesis. In other words, the claim and the counterclaim about the population parameter. Now let's take a look at the type of mistakes that one could make, because no inference can be done with absolute certainty. So there are two types of errors that you can make, what's called a type 1 and a type 2 error. Now, if the null hypothesis is true in reality, but based on what you saw in the sample, you reject the null, then you've made what is called a type 1 error. And the flip side of that is that the null is in fact false, but because of whatever you saw in the sample, you accept the null hypothesis. You've just made a type 2 error. Now, in this course, for all the types of hypothesis testing that we will do, we will focus only on type 1 errors and we will control for it. Okay, so anytime you do a hypothesis test, for our purposes in this course, we will be controlling for the type 1 error. So the next term or definition that I'll introduce for you is what's called the level of significance. That is the level of risk you're willing to assume about a type 1 error. In other words, what probability of making a type 1 error are you willing to assume? Noting that it is not possible to draw inferences with absolute certainty. Two very common levels of significance are 1% and 5%, which, in other words, what we are saying there is, I'm willing to accept a 1% chance of making a type 1 error, or I'm willing to accept a 5% chance of making a type 1 error. Now, based on the level of significance, one can make a quantified decision call on what represents an extreme value. So the way we do hypothesis testing, there's a fairly systematic procedure that you go about. The most difficult part of hypothesis testing is actually setting up the hypothesis, the claim and the counterclaim. You'll find it takes a lot of practice based on transforming a narrative into a claim and a counterclaim, the most common mistake being reversing the two. Okay, so because we are controlling for type 1 errors, in other words, the probability of making of rejecting the null hypothesis when in fact it's true, the claim and the counterclaim, or the hypothesis and null hypothesis, must be set up in a way that whatever it is we are trying to establish is the result of a rejection, because we are fairly confident when we do the rejection, when we are not as sure when the reverse happens. Okay, so the basic process in doing hypothesis testing is first setting up the claim, the hypothesis, the null and the alternate hypothesis. Once you've done that, you set a level of significance, that is, establish what level of risk are you willing to assume of making a type 1 error, and then you go look at your sample and compute the sample statistic. If the inference that you're making is about the population mean, you would compute the sample mean. If the inference that you're making, in other words, the claim and counterclaim you have, is about a population parameter, the sample statistic that you would observe is the sample proportion. So whatever sample statistic you get, you ask yourself the question, would I be seeing such an extreme value in the sample if the null were true as an equality? Okay, so let me repeat that. You ask yourself the question, would I be observing that extreme a value in the sample if the null were true as an equality? Or another way to state the same question is, what is the probability of observing at least as extreme a value as what I see in the sample if the null were true as an equality. If that probability is very low, and what we mean by very low, if we consider it very low, if that probability is less than our level of significance, the level of risk we are willing to assume. If our answer to the question is that it's highly unlikely that we would be observing at least as extreme a value as the sample statistic that we saw, provided the null is true, then we are able to reject the null with a fairly high level of confidence, meaning that the likelihood of having made a mistake is fairly small. So that is the basic procedure in doing hypothesis testing, and as we will work several problems so that you see the mechanics of quantifying the uncertainty and actually numerically deciding when the likelihood of seeing such an extreme value is too low or not low enough. But for now, just remember the basic concepts of hypothesis testing. You set up a claim and a counterclaim about the population parameter. Then you look at your sample statistic and you ask yourself, what is the likelihood that I would be seeing at least as extreme a value as this particular sample statistic, provided the null is true as an equality. So all hypothesis tests are done on the basis of assuming that the null is true as an equality, and then asking yourself whether you would see such an extreme value in the sample. So in the subsequent clips, we will go ahead and actually work out numerical problems to apply these steps and these concepts that we have just seen in this clip.